Solving two-step equations is going to follow the same rules that you followed or the same process that you followed for solving one-step equations. You need to remember that 1, our goal is to isolate the variable. 2, we do this by using the inverse or opposite operation. And 3, you always have to remember the golden rule. Whatever you do to one side, you have to do to the other in order to keep it balanced or keep two things that are equivalent the same. I'm just going to throw one more idea, and you can think of it 3 different ways as I have on the screen. You're going to still follow, like I said, that same process for solving one-step equations, but now you have to take something else into consideration. There's going to be 2 steps, so often that's going to involve 2 operations. Well, in order to do this, to isolate that variable, 1, you need to work backwards to isolate the variable. Oftentimes, we think of this as using reverse order of operations or working in the opposite order that we would normally work through order of operations. And then also, something else that is helpful to keep in mind is that we undo or get rid of numbers that are least attached to the variable. And depending on the equation, each of these 3 helpful hints might make a bit more sense or be a bit more helpful depending on which operations you're using in the equation. Let's get started. Negative 6g plus 7 equals negative 17. That means that when I take a number that I don't know yet times negative 6 and then add 7 to it, I end up with negative 17. These are a little bit more difficult to look at and just see what number would make that statement true. So instead, I'm just going to work through it using that process. 1, I'm going to cut my equation in half to remind me that whatever happens on one side, I have to do on the other. And then I'm going to work to get this variable g by itself. So you could think of it as working in reverse order of operations. Since you would normally multiply first and then add, to work backwards, you would have to undo the addition, then the multiplication. Or you can think of it as getting rid of the number least attached to the variable. Well, 6 has a much more significant impact on that variable than the adding 7. So let's undo the adding 7. So to undo that, I am going to subtract 7 on both sides. And remember, when I add 7 or subtract 7, that cancels out. They're opposite, they're inverse operations. Really, that equals 0. So what I have left over here is this term, which is negative 6g. And then my equal sign is still on that line. Then over here, I have negative 17 minus 7. You can go through the process of changing that to adding a negative if you want to follow those integer rules. Or you could think of it as being 17 degrees below 0 and it drops 7. Either way, you end up with negative 24. Now, you still don't have that variable isolated because you are multiplying it by negative 6. So you need to do the inverse of multiplying by negative 6, which would be dividing by negative 6, and you must do it on both sides. And you have to show me everything on both sides. From there, finish out what's left. Your negative 6 divided by negative 6 cancels out, leaving you with 1g. The 1 is not necessary. So g is equivalent to positive 4. Now, remember, you should never miss an equation because you can always plug your answer in and see if it works. So let's see if negative 6 times 4 plus 7 is indeed equal to negative 17. Well, now following order of operations, that would be negative 24 plus 7 is equal to negative 17. I'm running out of room, but negative 24 plus 7 is in fact the same thing as negative 17. So you have equivalent values on both sides of that equal sign. So you know that this solution of g equals 4 is correct. Equation number 2, 41 is equal to 8s plus 17. Cut that equation in half if that's helpful to remind you that you have 2 sides of a balance. And even though the variable is on the other side, you will work through this exactly the same. So our goal is to get this variable by itself. To do that, you get rid of the number least attached to the variable. Well, you're multiplying a number by s, then you're adding 17. So you're going to get rid of that 17 first. Since you're adding, you're going to do the opposite, which would be subtracting. And whatever you do to one side, you have to do to the other. And yes, you must show it on both sides of the equation. When you add 17 and subtract 17, that cancels out. Or you can think of it as a positive 17 with a negative 17. So over on the right side, you have 8 times your variable s. Keep your equation sign in there. And then 41 minus 17 is 24. Now, since you've worked backwards and got rid of that 17, now you're just looking at a simple one-step equation, which is 24 is equal to 8s. So to get rid of that 8, you do the opposite. The opposite, or the inverse of multiplying by 8, would be dividing by 8. And so you divide both sides by 8, and you end up with 3 is equal to s. And again, you could plug that into your equation, and you could check and see if 8 times 3 plus 17 is equal to 41, like you have on the other side. Well, with this side, you have 24 plus 17, and you would check to make sure, well, 24 plus 17 is, in fact, equivalent to 41. So you know that this solution, 3 is equal to s, is the one and only answer that makes this true. Your third equation that you are asked to solve reads like this: x divided by 4 minus 2 equals negative 7. Again, think of it as working in reverse order of operations. So if you were solving the problem, you would divide first and then subtract 2. So you work in reverse order to solve. Or you can think of getting rid of the numbers least attached to the variable. 4 is closer to x, so you would undo the 2 first. Or you can just think of it as working backwards. So the last thing I did was subtract 2. I caution you to think of the last thing you did, though, because you can use a commutative property to switch some of these problems, but I will certainly show you an example of that later. So I need to undo this negative 2 or undo the subtracting 2 by using the inverse operation, which is plus 2 or a positive 2. My 2's cancel out. So on the left side, I still have x divided by 4, and I still have my equal sign, and negative 7 plus 2 is negative 5. Now I have this number that when I divide it by 4, I end up with a negative 5. So to undo that dividing by 4, I'm going to multiply by 4 on both sides, and I'm going to show this on the same level, so it's very easy to see that you kept this balance by doing the same thing on both sides. And dividing by 4 and multiplying by 4 cancel each other out because they are inverse operations. So on this side I have x, and over here I have negative 5 times 4 equals negative 20. Of course, you can always plug that in and make sure that it works. So that would mean that negative 20 divided by 4 minus 2 is equivalent to negative 7. You would divide first, so that would be negative 5 minus 2. And I'm going to think of that like temperature. If it's 5 degrees below 0 and it drops 2, my new temperature would be negative 7, which is equivalent on both sides.